E4, block on incline, no friction. I'm going to give you the sketch first, but when you're given these problems in your book, there are diagrams, but we're going to give a sketch version of the diagram. So here is the ground, angle theta, and there's a mass here. And I'm going to choose down as the plus direction. Now we're ready to do the force diagram. Now here, I like to do the force diagram on a slant, so that it kind of like goes with, kind of helps me see things better this way. But you know, it's up to you. You don't have to do this, but see, now it's easy to put the mg straight down, and there's going to be a normal force where the table is pushing up on the block. And then the only question here is, how does this angle relate to this angle over here? Well, that angle is complementary to this one. And that's the one that's made with respect to the vertical. So that means this angle here is the theta angle. I had a teacher that once said, if you collapse this, then this would collapse. It's sort of a shortcut, because the angles are always either the same or they're complementary. But there is the formal argument with the complementary case. This is 90 degrees here. Okay, so then we go to the equations. And the equations say here, sliding down the incline, okay, along the incline, would be mg sine of theta, and that's going to equal ma. And then for the other direction, I have the normal force minus mg cosine of theta equals 0. So these are the two equations, where if you want to solve them, you're going to have the acceleration is g sine of theta from the first one. So we're doing step 4, the solve, which is very fast, and the n is mg cosine of theta. This is what I get. But here I should point out the question was find the acceleration. So just put that in there in the given. And we are finished. This is the answer. Didn't ask for anything else. Are the units correct? Yes, because the sine of theta doesn't have, it's not going to introduce any units, and A is G, same units as G. And here, this has units of force, mg. So that's good too. So now it's time to reflect that the answers are reasonable. So I'm going to do here, check 1. Suppose the angle is 0 degrees. Well, there's no incline then. It's just going to sit there. There's going to be no acceleration. So let's see what happens. The limit as the angle goes to 0 degrees for the acceleration is the limit as the angle goes to 0 degrees of g sine of theta, and that's going to be g sine of 0 degrees, and that's going to be 0. Sine is 0, 0. So it just sits there. We have a case where we're just sitting there, and n should be then mg. So let's check out that. So if we take the limit as theta goes to 0 of the normal force, we want the limit as theta goes to 0 degrees of mg cosine of theta, and that's mg cosine of 0 degrees, and the cosine of 0 degrees is 1. So that's mg, checks out. check 2. Suppose the angle is 90 degrees. Well, if it's 90 degrees, there'll be no normal force. They'll just fall down with acceleration A equal to G. So if we do that, in fact, we'll just go ahead and do this. The acceleration is G sine of theta. As theta goes to 90, the sine goes to 1. You have G sine of 90 is 1, and that's G, the free fall. And then here, the normal force, which is mg cosine of theta, when the theta goes to 90, you're going to have mg cosine of 90, and the cosine of 90 is 0, and you get 0, checks out. Very nice.